Now that we have seen what are reflexive and symmetric relations, let us see these concepts in action by solving a few problems. Consider the set A equal to 1, 2, 3, 4, 5 and let R be a subset of A cross A, and I am going to write R as these elements, set of all these elements. Now the question is R a reflexive relation? So A has precisely 5 elements, and in R I see 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Yes, R is reflexive because every element of A has an A belonging to R, and hence R is reflexive. Consider this relation as set of all A, B such that A, B are natural numbers and B is equal to A square. So whenever I write A, B, B will be A square. Is this relation reflexive? So let me just try enumerating R. So R will have the elements 1, 1. I'll start with 1, the first natural number. So 1, 1 square, which is 1. And then I go to 2, 2, square is 4, 3, 9, 4, 16, 5, 25 and so on. Now you see 1, 1 belongs to R. 1 is 1 square and hence it is there in R. But 2, 4 is not equal to 4, 2 because 2 is not 4 square and hence, but 2, 2 does not belong to R. You must be guessing the reason, because 2 is not equal to 2 square, and hence the reason is the same for all the other natural numbers such as 3, 3, 4, 4 and so on. We don't have these elements in R, and hence this is not a reflexive relation. Consider the relation on the set of integers R equals x, y such that x square is equal to y square. So R will be having all those elements whose squares are equal. So is this relation reflexive? Is this relation symmetric? So R is going to have all those elements such as 0, 0, 1, 1, 1, minus 1, minus 1, 1. You see, if you are observing, you can see that minus 1 square is equal to 1 square. 2, 2, minus 2, 2, 2, minus 2, 3, 3 and so on. So these will be the elements of R. Now, for a relation to be symmetric, A, B should be equal to B, A. Is that happening here? 1, minus 1, the squares are 1. And then minus 1, 1, again the squares are 1. So for any element A, minus A, it is always equal to minus A, A. A and minus A belong to integers, and hence this relation is symmetric. Consider this relation on natural numbers. R equals A, B, where A and B are natural numbers and A into B is 14. Is this relation symmetric? So what are the elements of this relation? We have to pick only natural numbers, and hence R is going to have 1, 14, 2, 7, 7, 2 and 14, 1. Anything else? No, it is precisely these elements because we are concentrating only on natural numbers. 2, 7 is there, 7, 2 is there, 1, 14 and 14, 1. All are respectively equal pairwise, and hence this is a symmetric relation.